Okay, welcome back. This is day 3 of a 4-part course on teaching the microbit to 4th graders. And today we're going to get into sound, and really more importantly, what we're going to do is wiring, because wiring is critical to going on to the next one, which is about using a servo, and also this one, which is about using headphones and sound. This is the way that we ran it today. So we started off having the kids talk about with themselves what is sound in the center of the classroom. And then we went over some sound basics. I showed them an example of a microbit that was using light to play a sound that was keyed to the light level, and that was hooked up to a set of speakers. You can use speakers exactly the same way as you use headphones. They wire up exactly the same way. And then we did cover how to do alligator clips and do a little bit of basic wiring. So the kids understood how to press down on the top of an alligator clip and get the jaws to open. And that was actually kind of tricky. There was a lot of consternation about how slippery they were. And then we also did a quick overview of how to manage projects, because in this example, a lot of kids used like the note playing functionality to play a specific set of notes that they learned in other music classes. And they wanted to keep those. So understanding that the projects were actually retained on their computer, well, via cookies, was fine for them. So we wanted to understand, also have them create a new project and understand that they weren't going to reuse their existing projects. So after we set that up, we then did an activity. And so the kids were going to build a very simple A plays a certain sound, B plays a certain sound, A plus B does a certain sound, and get that onto the microbit, get that wired up to a set of headphones. And that was really the sum total of it. If we were able to get past that, then we went into a little bit more advanced stuff and showed them how to key sound to an input like light and the accelerometer, a compass, and I'll show you how to do that. And it's pretty simple, but it's cool. It kind of gives you a sense of, oh, I'm going to translate, some input value and turn it into a sound, and that's cool. And then we gave them some more time for doing some hacking and demonstrating their microbit code to other kids and walking it around. The battery pack information that they had for last week was very helpful with that. And then finally, of course, it was just cleanup. So let's talk about things that worked. We started off without having the connections pre-wired, but in the second class, we obviously had that. So that was actually really beneficial. That saved some time. Using 2 different colored wires was really valuable. We didn't always do that, but being able to debug using 2 different colored wires was really cool. Also, working through those connection and debugging issues with the kids was kind of cool. It was very problem-solving. The kids already knowing how to use the battery pack helped them when they wanted to move it around. And having a demo time at the end was really valuable because the kids got a sense of kind of fulfillment and achievement by having something to show. So let's dig into the debugging aspect of this, because it's really critical to understanding the whole wiring thing and getting that all right. It starts with 2 directions, basically. Either the microbit makes noise, it puts out something over the headphones, or it doesn't. And if it makes the noise, then probably the kids are worried about, you just don't have it's not playing the noise we want, right? And then you look at the code, make sure that the correct version's downloaded. Show in folder didn't show up for some kids during the download. And that just turned out that the machine was almost full. So they needed to go and kind of empty out their downloads folder to make space for the new code. Okay, now let's get on the more interesting one, that when the microbit doesn't make noise. So you're going to kind of debug it from the computer all the way to the headphone. Starting at the computer, you just want to make sure that their code does something. Sometimes they'll use commands that play a sound super fast and you won't hear it, or it's not on the right event handlers, the right inputs. First, look to see if there's a software issue. Show me your code and let's walk through it. And then use the headphones to actually connect to the computer and hear it. If that's working, if you think, okay, cool, they've got good audio coming out of their headphones, the next thing to look for is a short or inverted connectors. Are you going to the right locations? And then if you're pretty sure about the wiring, then the next thing to do is to look at the actual headphones. Maybe they're busted. But given that you actually tested it on the computer, that's probably unlikely. But we did have a bum set of headphones that kind of went around. So it's something to look at. So let's talk a little bit more about the headphone jack, because the image that's on the microbit site is actually a touch simplistic, but it's good enough probably. So just to drill down to it a little bit more, what you're going to want to do is probably connect one alligator clip to the very front of the headphone. And that gets you into nicely set up for the mono case, if you have a set of mono headphones. If you want to use the right channel as opposed to the left channel. You can certainly do that by like, kind of moving the first alligator clip back. But if you have headphones with a microphone, you're going to make sure that you clip it onto that second line. So I guess, the third line, left, right, and then ground, as opposed to the microphone. So that's not going to work. So if you have a set with microphones, just watch out. Okay, and then when it comes to wiring, we found that putting the alligator clips kind of on the sides like that, kind of bring it in, was the most reliable way to make a connection that didn't slip around as the kids moved it around and used the battery packs. And if you see LED indicators like what's on the right-hand side with 2 little points or 3 little points, that just means that you've shorted somewhere along the line. You're not hurting the microbit in that case. You're just not going to hear any audio. So you don't want to get that. And you'll see that blinking as you get kind of unsteady connections. It'll kind of blink in and out of short a little bit. So there's that. All right, so let's have a look at the code. So here I am at a new project, and we don't need on start. We don't need forever. I'm just going to go, and this is what we showed them initially. So just start a melody, and now you can just press A. That's cool. All right, let's get rid of that. And okay, let me just bring it up, but not yet actually use it. So you can also show the kids this wiring diagram down below. And this one shows a stereo headphone set. So it's got 3 lines. That first one is the left, then the right, and then the ground. And again, if you have a microphone on it, that means that you're going to have to go and use that third one, not the fourth one. So you're going to have an extra item right at the end, and that's not. Okay, so just moving on, we did a couple A, B, and then do different melodies. Sure, whatever. And, they liked funk as an example. And this was good enough, right? If you can get this and get this downloaded to the microbit, you've got a gratifying example for the kids right there. All right, so moving on from that, if you want to do something a little bit more advanced, what we're going to do is just turn off the sound here so you don't really hear it. But we'll get rid of these, bring on the forever, so it just is a continuous loop. And then we'll have the ringtone. So this is just going to play a tone, but we're going to correlate that to the input of the light level. And this just means that you're going to get a low frequency if this light level is low, and you're going to get a high frequency if it's high. And you can see it outputting here. I'm not going to turn it on because it's just kind of annoying. But it really does make for a really cool demo as you kind of put your hand over it and then you move it closer to the light and back and forth, and you can kind of get a different set of tones. And it's really cool at the very beginning because it kind of knocks kids out of, we're just going to make some music or whatever. Oh, wow, we're going to actually correlate light level to sound. I've never seen that before. I've never heard that before. So it's really cool. And there are a couple of different things that you can do at that level. You can do compass heading. You can do temperature. Tonal temperature is not really interesting because it's not going to vary that much. And then acceleration. And acceleration is actually kind of interesting because that level is going to change as you move the microbit from the center line to the right. Because this actually goes from negative values to positive values, obviously a negative value isn't going to output any sound. So you'd actually have to do a little bit more there if you wanted to go and do something like along the lines of do the absolute value of it. And so we'd grab that acceleration, put it there, and then put that there. And then because it's using the absolute value, you can actually move from side to side, and it'll maintain a positive value, and you'll still get sound. And if you want to go even cooler than that, let's see, we can do a little bit more math and do, again, the absolute, and we'll do acceleration this time, but in Y. So there you go, X and Y. And then we're going to do some math where you just add those two values together, put that in there, put that over there, put this in here. And now any way you pitch and roll it, you're going to get different sounds all the way around. And that's pretty cool, actually. All right. So that's about it for the code part. So what to practice going into this? Definitely try it out yourself. Wire up some microbits for sound. Get a sense of how those wiring connections work, because in the next one, we're going to be using servos, and that's 3 connections. So if 2 connections is tough, 3 connections is going to be even tougher. So also dealing with the kind of slippery alligator clips, maybe even finding a way when the plastic sheath kind of disengages from the alligator portion of the clip and back onto the wire, how to get that back onto the clip is kind of interesting to work through. And then, yeah, as I showed you with the light level and the accelerometer, just try out sounds with different input sources and see how that goes. All right, so that's my spiel for today. And as always, like me on YouTube, follow it, that's fine. And I look forward to seeing you in the 4th day, which will be our last, coming up soon, coming up next week.